Recall from Lecture 3 the uneven distribution of energy received by the Earth from the Sun is shown here. Latitude is shown on the vertical axis and month of the year on the horizontal axis. The paler the pink color, the more energy received. Review what you learned in Lecture 3 about the factors controlling the distribution of energy on Earth and explain for yourself what this diagram is showing. The Earth's energy balance is determined by comparing incoming and outgoing energy. In the previous slide, we saw how incoming energy varies across Earth. This incoming radiation is measured at the top of the Earth's atmosphere. As it passes through the atmosphere, some of it is reflected by clouds and the atmosphere, and some by the surface of the Earth. Reflected energy does not change wavelength, and as we learned before, the amount is dependent on the albedo of the surface. The blue map shows energy reflected. Bluer colors show less energy reflected, and white colors more energy reflected. Notice the white band near the equator. These are clouds located at the ITCZ, which are causing much of the incoming radiation to be reflected. You might note that the poles are darker blue, indicating little reflection. Why would this be if the poles are covered with snow and ice? The time of year this map was made, in September, was a time when both poles were receiving little energy. Therefore, there was little energy to be reflected. The middle map, the orange map, shows outgoing long-wave radiation, measured at the top of the Earth's atmosphere. Notice over the subtropical areas the high amounts of energy re-emitted from Earth to space, the dark orange colors. Here, there are no clouds, and therefore no water vapor to absorb outgoing long-wave energy. At the equator and towards the poles, increasing cloud cover increases the absorption of outgoing radiation, so less makes it to the top of the atmosphere. The bottom map shows the net radiation received. The incoming minus the outgoing. The net radiation at the equator is positive, even though both the reflected and outgoing energy were high. This is because of the much higher amounts of energy being received at the equator. In the next slides, we will break down the energy balance for the Earth. As we go through the Earth's energy balance, keep in mind 3 important points. First, at all 3 levels, incoming and outgoing energy must be in balance, or should be in balance, meaning the Earth's climate system is in equilibrium. Second, all objects with temperatures above absolute zero radiate energy. And as we have already talked about, energy is proportional to temperature. Energy reaches the Earth from the Sun. This incoming radiation totals 341 watts per meter squared. 29% is reflected by the atmosphere. 23% is absorbed by the atmosphere. And 48%, or about 238 watts per meter squared, reaches the Earth. We can use the type of data in slide 19 to determine an energy balance for the Earth. To do this, we have to consider energy balances at 3 levels: the Earth's surface, the top of the Earth's atmosphere, or TOA, and the atmosphere in between. The next few slides show the energy balance for the top of the atmosphere, the Earth's atmosphere, and the surface of the Earth. Many measurements and pages of calculations go into estimating the Earth's energy balance. Every year, scientists gain new information, so depending where you look, the exact numbers of the energy balance vary. Remember from Lecture 2, science is not static. Scientists are always finding new ways to make measurements and gathering new information in order to understand things better. Review the next 6 slides, and use this information to help you determine the answers to the energy balance in the activity.